Greetings, QCS build fans. So here's the big day. Welcome to the server build. So as you can see, we've got lots of hardware, and it's all going to go in this behemoth of a box. So this is specifically, it's an Antec 4U rack mount chassis. So, and in it, it has the capability for 6 optical drives, 3 on this side, 3 on this side, or 2 external 3.5-inch drives, floppy drives or media bays or whatever you want to do. Has a USB 2.0 header on it, has an integrated dust filter built into it, and it is lockable. Although the last 2 of these that I've done, usually I actually don't get any locked because they're in a secure area, so it's more just for dust filtration. So, however, with this particular configuration, we're actually going to be taking these 3 5.25 bays out, and we're going to be doing this guy. So this is a StarTech and we don't need the nannies right now. This is a StarTech 3 5.25 bay drive to 4 hot swap 3.5-inch hard drive unit that is trayless and is SATA. So this is the 4th one of these that I've used. These are totally awesome. They also make a version that doesn't have the machined screw holes on it, but at the same time it works just as well. It's a little older styling unit just because it has the SATA logos on the front and it's black. So, but yeah, these are totally awesome. And file 13. Oops, I missed. Anyways, so in these, if you notice, this is actually lockable here. You actually have a hard drive indicator light and a power light, but this totally opens up like so with our SATA backplane in the back, and these metal doodads right here kind of look like scoops on them are actually spring retainers that actually put pressure on the hard drive. That's one of the things about this particular unit versus other units that I've used, specifically the Roswell unit that is in the big black box in our Threadripper system. If you saw it from the last video, that is a huge difference. So that's a tray system, but also because it's plastic, the whole unit is plastic itself, it flexes, and so you tend to have I/O drop-off issues occasionally with it. This particular unit, it is plastic on the inside, but the whole housing is machined aluminum, and it is totally rock solid. Like I said, I have 3 others of these out in deployment right now. 0 issues. Totally awesome unit. So that is actually going to go in our left bay over here for this guy. Drop this down for the moment. Other configurations of this is this case actually does come with adapters for the cages. So each 5.25 base set actually has a cage that this will actually go into, and each cage can hold 4 drives within 4, 3. 1, 2, 3, 4. believe it has hole spacing for 4. There we go. 1, 2, yep. Has hole spacing for 4. Now that I take it off, has hole spacing for 4 hard drives in each cage, plus the bottom additional 2 more hard drives inside of this. So yeah, it's quite an impressive box. I wish Antec still made this. Unfortunately, they don't. This thing is heavy gauge solid steel, so it is heavy. Picking it up, it weighs about 30 pounds, and that's empty. That's just the case itself. That's before we put all this stuff in it. So by the time we get all this in here, plus our caddy, this thing's going to be heavy. It's going to weigh roughly about 40 to almost 50 pounds. Bigger machine, the first machine that we did was a Threadripper system for a client in one of these boxes. And the original plan was we were going to wall mount rack it. The second iteration of this system, which is actually almost identical to this configuration, that's what we did. Is we actually ended up wall mounting it with a vertical wall mount rack, which keeps it up and out of the way, and it's great for small businesses that don't have a ton of room for like a big 4U, or not 4U, a 4-post rack, and a whole bunch of back spacing. So this makes it nice because we can just take this, we can just mount it straight on the wall, and then it's up and it's out of the way, and we don't have to worry about it a whole lot. And it makes it fairly earthquake proof, because then, you know, it's just attached to the wall, assuming your wall doesn't fall down. But of course in Idaho we don't have to worry about as much. So anyways, so okay, alright, so that is our case. This has options. If you weren't using these, it would have options for 2 120 millimeter fans up front and 2 80 millimeter fans in the back. The closest thing you can get to this is Roosevelt actually makes several server 4U chassis in several different configurations that are very similar to this unit. Although I would suspect that the heavy gaugeness of the steel is not as robust in that newer unit, probably for cost reasons. So I mean, this particular case, they're fairly old. I mean, like I said, you can't get these anymore. You have to buy them on the third-party sites to be able to get a hold of one. And this is the last one with all the internals and everything that I could find. So, and I have a couple of spare parts for them, but because, like I said, this is the third one of these machines that I've done. But yeah, it might be the last, which is kind of sad because I really like this case. So, but is what it is. Anyways, so next we're gonna have this is our power supply. Big server builds like this, I always do a super high efficiency power supply. This one is a Evga 80 plus gold power supply. It's a 92% efficient, so technically it should be a platinum. However, probably because of the power curve at certain loads, it probably doesn't maintain efficiency enough at the platinum level to actually be platinum certified. So last couple of machines that I've done, I've actually used Antec high current power supplies that are platinum graded, and those have been really, really awesome. But unfortunately, as of current market conditions right now, I can't get those. So next best thing is actually the Evga, so which everybody's has said that is a very good power supply. And realistically, there's only about 5 major manufacturers of power supplies. So it's not like you go from one power supply manufacturer to another power supply manufacturer in the same price range, and you're going to see a huge difference because realistically they're all basically kind of the same. So but this one is totally modular, and you'll see that during the build, which makes it nice because we won't have a whole lot of extra cabling to necessarily hide or anything like that. So totally awesome. So moving on to the important part. So this is going to be the heart of our system. This is a EPYC 7282. Yeah. So this is a 7282 AMD EPYC processor. This runs 16 cores and 32 threads with, I believe it's 96 PCI Express lines. This is a Rome chip. This would be the second one of these I've done. The other sister box to this machine ran the 7252, which is the 8-core version, and is a totally rock solid, amazing machine, and is humming away about, not even a mile down the road from here. So yeah, this one's been totally awesome. So this is the processor we're going to do. Is going to be our EPYC. That is then going to go into our AsRock server workstation board. Specifically, this one is our EPYC D8-2T. This board is the same board that I used in the last build that I did like this. And this one is really, really nice. It gives us eight-channel DDR4 memory capability. We're actually only going to be using quad channel because we don't quite need the extra bandwidth for 8-channel. So, but this is our board. So you can see we've got 8 DIMM sockets, or DIMM slots. This is our SP3, also same size as a TR3, or TR4, excuse me. DIMM socket, or not DIMM socket, CPU socket. We have 4 PCI Express 16 slots, which are fully pinned and fully capable of PCI Express 16. That is the major advantage with EPYC versus Threadripper, is you get another doubling of your PCI Express lanes. Just like you did from AM4, which is the desktop platform, to TR4, which is the Threadripper platform, you get double the PCI Express lanes. Well, in EPYC, you get another doubling of those PCI Express lanes. So we have 4 PCI Express 16 slots, 3 PCI Express 8 slots, and all these can be ran all at the same time with without any PCI Express lane loss. So, which is totally awesome. We also have a USB 3.0 header. We have these guys, which are our mini SAS header ports. This gives us the capability of 4 SATA channels for each one of these connectors. So we can actually attach, without any other add-on cards, we can go ahead and attach up to 9 hard drives, which in a couple of machines we have done. So it makes it really, really nice. So we'll actually end up using this one here, which is our SATA 0 through 3 header for this guy. It actually, and then also it has two M.2 slots, which are PCI Express 3 4-speed slots, which in those we'll get to here in a second. We'll be putting M.2 slots in for our operating system. And on the back side, you've got VGA header with a single serial port on board. This actually is a 1 gigabit diagnostic port that's built into it. 2 USB 3 ports on the back, and these two is what make this board extra special. These are 2 Intel Extreme 10 gigabit ports, which we are going to be using both of these on this machine. So yeah, awesome. Because this machine is going to be it's going to be running as a virtual machine server, but also we're going to use it as a file server / Active Directory controller. So, yep, this is totally awesome. The other cool things about this is we do get a diagnostic readout on the board, which is nice, especially if you get strange memory configurations or something like that. So that's our board. So awesome. So we'll put that back in the box. Okay. So the RAM I was talking about. So this is Nemix RAM. This is Samsung, I believe it's B-die. But this actually is basically Samsung memory, and this is DDR4 3200 ECC registered, and these are 16 gig sticks, and we're going to be running 64 gigs of quad channel memory on this guy, which is stupid fast. And this is what we're going to be using for our OS. So we're actually going to be using 2 Samsung Evo Plus M.2 drives. So the other 2 machines that I've done similar to this with similar configurations, we actually use the Pro versions of these. This particular customer wanted a system that was a little more budget conscious. So these are a little faster on the write side, same speed on the read side as the M.2 Pro 970s, but they are about $100 a piece cheaper. So the other machines, the Pluses weren't available yet. And I've ran a Plus in my primary rig for better part of a year now, and have had 0 problems with it at all. So been a totally very solid. Anytime I do NVMe's in a server or in a production environment, I always do Samsung, because it is the one SSD I absolutely trust. So there's that. Okay, working our way down the line. So these are our 4 data drives. This one, for example, and I will go ahead and take it out. Got the static bag there. This is our 7200 RPM Seagate 2 terabyte Exos drives. We've got 4 for our hot swap bays here. These are going to hold all of our data for the system. We've got 4 of these, so 8 terabytes functionally. We're going to run these in a RAID 5 configuration through Windows Server. So in doing so, we're actually going to have 6 terabytes effectively. because we're going to have redundant capabilities. So if we lose, if we lose one of these drives, the system will automatically fail over, and we'll still be able to stay up and running while we're getting our replacement drive. So, other iterations of this machine, we have done an integrated backup drive. So there is one system out there that has a 16 terabyte Exos drive in it. The other system has a 10 terabyte Exos in it. The 16 is extremely impressive. That is one fast drive for a traditional mechanical drive. But again, to keep costs down on this particular system, we're not doing an integrated internal backup drive. Just for double redundancy purposes. So the one nice thing is most of a lot of the data is actually going to be running on our Avast Cloud Care cloud backup system that I manage for this client, and so all the important data will actually be backed up over the cloud anyways, so that won't matter. So then we got our Noctua fans. So one of these, this is our 120 millimeter fan. That's going to go up front here, right there. And then we've got our two 80 millimeter fans, and those are actually going to go in the back here. So we'll have flow through ventilation. And then if you notice from the last video, when we did the Arctic cooler installation, we have our Noctua NH9U cooler, and that one is going to be our CPU cooler. So we'll have flow through air. So this is the same configuration I used in the last EPYC server build that I did, and it stays very, very cool, and it's totally awesome and totally quiet. That is the beauty of using a 4U chassis instead of using a 1 or 2U chassis. With one, we've got room so we can use big fans. Big fans spin slower. They also create less noise as they spin, so we don't get the horrible data center sound that you will get in most data centers because we're using 1U or 2U servers with tiny little 40 millimeter fans, sometimes 30 millimeter fans, and they're horrendously loud because they're spinning anywhere from 1,000 to 9,000 RPMs. So they're extremely hideously loud. Every time I walk into a data center, I always feel like I should be wearing ear protection because they think you get 30 of them in a room, and it's just, they're loud. Small businesses, the last thing you want is a server whistling away inside of a closet that's centrally located in a building. So every time somebody walks by that room, all they hear is this loud, insidious hum all the time. So, yeah. So we don't have to do that, which is ideal. So last but not least, and some people are going to go, why is he holding a graphics card? So, this particular machine, the board, does have integrated video. However, that integrated video is not going to be enough video memory, let alone have enough video oomph to be able to run the virtual machine part of the system. So with that, because we are going to be running 5, possibly 5 virtual machines with this up front, plus the server part of it. Server part of it, we don't really necessarily need high resolution graphics. However, for the virtual machine, the client virtual machines, we do. And we don't want any lag to happen. So that's what this guy's for. It's 8 gigs. It's a relatively inexpensive card. This is the AsRock Phantom Gaming RX 580 8 gig overclock card. We're not going to be overclocking it, obviously. It's literally going to sit here and hum away for the most part. This card is not going to do a whole lot, but what we do need out of this card is we need the video memory out of this card. Run a lot of desktops, run a lot of virtual machines, you need a lot of virtual memory and virtual data throughput. So that's what this guy's for. So this is your standard 2-height video card. This one has the smaller fans on it because actually this card is not very, if you notice, it's not very tall. So, but yeah. So later on, if we want, we can add a whole bunch of monitors to it and everything for monitoring, but realistically this machine for now is actually going to run headless. So this just gives us enough to be able to do everything we need to be able to do without having the video lag. So, and that's it. So we're going to be splitting this video into multiple parts, just because of the fact that this build will take some time. So I should go through it in detail. So this is the intro. We'll go ahead and we're going to do the chassis prep build video next, and then this will split probably into 3 or 4 videos. So stay tuned, and this one will go up first, and then the chassis prep will go up next, and so on. So we'll see you in the chassis. Bye for now.